Today we're going to learn how to classify polynomials. And the major part of this lesson is just so you understand what I'm talking about when I reference different terms throughout this unit and the next unit, which is also on polynomials. So we'll just talk about the vocab review together. The first one says that the terms in a polynomial are in descending order by degree. The degrees decrease from left to right, and this order demonstrates the standard form of a polynomial. For number 2, the degree of a polynomial is the largest degree of any term of the polynomial. Number 3, in a polynomial, the coefficient of the term with the highest degree is the leading coefficient. Number 4, a number on its own is called a constant. And number 5, the exponent of the variable in a term determines the degree of that term. If we scroll down and look at this example, we can fill in our vocab terms. So let's start with this term here. That is called the degree of a polynomial. That's the overall degree. It's always the largest degree. This number right here is called the leading coefficient. And I generally abbreviate leading coefficient as LC, which you'll see me do frequently. And then let's just label some terms. So this right here is pointing to this term, which we would, in this case, call the cubic term. This term has an exponent of 2, so we would call this a quadratic term. This term has an exponent of 1. That's called the linear term. And then lastly, this number right here, a number on its own without a variable, is called a constant. So naming polynomials is important. It's important because you'll hear different language being thrown out when talking about different problems, and you have to understand what we're talking about. So there's two very, very important columns. There's the name using the degree, and there's also the name using the number of terms, both of which can change. So let's start with a degree of 0. When you have a degree of 0, this would be called a constant. That's because it's a variable with a degree of 0. If I gave you an example, this is only examples. I could give you 6, which is technically in a polynomial 6 times x raised to the power of 0. Remember that anything raised to the power of 0 is 1, so 6 times 1 is just 6. But that's your constant term. In this case, the number of terms is 1, so the name using the number of terms is called a monomial. If we have a degree of 1, that's called a linear function. An example could be x plus 3. And in this case, we have 2 terms. If you have 2 terms, it's called a binomial. Next, we have a degree of 2, which is called a quadratic function. An example of a quadratic could be x squared Let's do just 3x squared. So 3x squared is just one single term. Of course, we could have more. We could have 3x squared plus 2x plus 3, which would be 3 terms. But in my example, again, just an example, you only have one single term. So we would call this a monomial. Next, we're going to look at a degree of 3, which is called a cubic function. And my example for a cubic function could be 2x cubed minus 5x squared minus 2x. And in this case, we have 3 terms. 3 terms is called a trinomial. Next, we have a degree of 4. This is called a quartic function. If I have an example of x to the 4th plus 3x squared, this particular example is only 2 terms, and 2 terms is a binomial. A degree of 5 is called a quintic function. It's Q-U-I-N-T-I-C. I could have an example of negative 2x to the 5th plus 3x squared minus x plus 4. This particular example is 4 terms. So we don't have a specific name for a polynomial with 4 terms, so we say polynomial of 4 terms. So anything over 3 is just going to be named polynomial of 4 terms. So we have monomial, binomial, trinomial, polynomial of 4 terms, polynomial of 5 terms, polynomial of 6 terms, and so on. Also, 5 is the largest degree that has a specific name. So any degree larger than 5, such as 6, we would say the name using the degree is a polynomial. I should write out the whole thing. Polynomial of degree 6. Okay, and that would continue for any degree after that. So this chart has 2 things going on. Yes, we named the degree using, or named the polynomial using the degree, but we also talked about the number of terms. So if we scroll down to the examples, we need to do both. The directions say to write each polynomial in standard form. Just a quick reminder, standard form is largest exponent first, decreasing from there. After you write it in standard form, you're classifying by degree and number of terms. So let's start by looking at negative 7x plus 5x to the 4th. If I write this in standard form, the largest exponent comes first, and then the exponents descend from there. So this is 5x to the 4th minus 7x if you write it in standard form. Now, if I was to label this by its degree and by the number of terms, in this case the degree is 4, the number of terms is 2. So let's list this. Degree is the largest degree. Number of terms is 2. So we would call this a quartic, that's degree of 4. And 2 terms is a binomial, so quartic binomial. This is the name. For number 2, if we were to put this in standard form, we have 3x cubed plus x squared. And then we have 2 common terms. We have negative 4x plus 2x, which we can add together to negative 2x. So this here is your standard form equation. And from here we can see that our degree is 3, and we have 3 terms. If I was to label this using the degree, it's a cubic, and the number of terms is trinomial. Okay, and for the on your own section, I'll do the first two and then I'll let you check your answer for the second two on my website. So the first one, if we were to write this in standard form, we would write this as 4x squared plus 3x. So the degree is 2, and there's 2 terms. So I would label this as a quadratic binomial. And number 2, if we were to write this in standard form, we have 5x cubed. We need to combine our like terms. We have 4x and 7x, which makes 11x, and then minus 1. Degree of 3, 3 terms. That's going to be a cubic trinomial. And please try to do 3 and 4 by yourself. Like I said, the answer key is on the note sheet posted on my website. And for the last section of the notes, here you just have to identify the degree, the leading coefficient, and the constant term of each function. So just making sure you understand the vocab we went over on the front page. For number 5, this function is already in standard form. We have 2x to the 4th plus 5x squared minus 7x plus 1. The degree of the function is always the largest, the largest exponent, which in this case is 4. The leading coefficient is always the term that goes with that. It's the leading coefficient of the term with the largest exponent, so in this case, it's 2. And lastly, the constant term is the only term without a variable. Technically, it does have a variable of x to the power of 0, but recall that x to the power of 0 is 1, so 1 times 1 would just be 1. But your constant term is the term you visually see without a variable. And lastly, number 6, we have 7x cubed plus 6x squared plus 2x minus 5. The degree is the largest exponent, so we have a degree of 3. The leading coefficient is in front of that term, which is 7. And the constant term is the number by itself, which is negative 5. And that's it for today's notes. So if you have any questions, please let me know. And that's it.